Hi guys, in this video we are going to discuss factoring polynomials. Okay, let us just focus in lesson 2. Lesson 2 is all about factoring difference of two squares. Okay, of course we have our objective. After watching this video, you will be able to factor completely and accurately difference of two squares. Right? We need to recall first about perfect squares. Okay, perfect squares are numbers or expressions that can be expressed to the power of 2. Examples. Number 1, we have here 4. This can be expressed as 2 times 2. Okay, this is the reason why 4 is being called as perfect square, because this is the result after multiplying the number by itself. And this expression also can be transformed into exponential form, 2 raised to 2. Alright? Then, number 2, 9x squared. Okay, this is a combination of the numerical coefficient and the variable. Okay, both are perfect square. So, 9 is the result after multiplying 3 by itself. And x squared is the result after multiplying x by itself. Okay, this can be transformed also as exponential form, quantity 3x raised to 2. Right? So it is very important, guys, to remember your knowledge about perfect square numbers. Okay. Now let us answer this activity. Determine which of the following is a perfect square. Write P if it is a perfect square and N if it is not. Number 1, 16. Can you imagine if a number multiplied by itself, the result is 16? Yes, it's 4. So that means 16 is perfect square. Then number 2, 12. Can you imagine if a number multiplied by itself, the result is 12? There is none. So 12 is not a perfect square. Then 25. What is that number multiplied by itself? The result is 25. Yes, it's 5. So this is a perfect square. Then number 4, 8x squared. We have here the numerical coefficient, which is 8 rather. Can you imagine of a number multiplied by itself? The result is 8. There is none. But x squared here is a perfect square. Okay, we cannot consider this one as a perfect square term. It's because it should be both. So this is not a perfect square number. Okay, then 36 y raised to 4. Okay, 36. What is that number multiplied by itself? The result is 36. Yes, it's 6. Then y raised to 4 is also a perfect square. This is the result after multiplying y squared by itself. Okay, so this is a perfect square number. Okay, so it is very important, guys, to recall your learning about perfect square numbers. It is very necessary in this lesson. Okay, now let us talk about squares of plus and minus. Okay, so we have here the expression quantity x plus 3 times quantity x minus 3. So what are we going to do with this? We need to determine the product. When we say product, we need to multiply these two binomials. Alright, so this is the sum because of this operation and the difference because of this operation of two terms. Two terms refers to the terms in the binomial. We have 1, 2, and the other binomial also we have 1 and 2. Alright, now how are we going to determine the product of this expression? Well, of course, by applying the concept of distributive property of multiplication or the FOIL method, we can determine the product. In this case, we will use the distributive property of multiplication. Okay, so meaning to say, we will multiply each term here to the term in the next binomial. Okay, first we have here x. We will multiply this one to the first term, the next binomial. The result is x squared. Then multiply x again to the next term of the next binomial, negative 3. The result is negative 3x. Then we will do the same in the next term in the first binomial. Okay, positive 3 times x, that is positive 3x. Then positive 3 times negative 3, that is negative 9. Alright, then after doing so, we will combine similar terms, okay? So these are the similar terms since they have the same numerical coefficient and they have different signs, that means this will become 0. So what will remain in this expression is x squared and negative 9. Okay, so recall the topic about special product, particularly the product of the sum and difference of two terms. Okay, this is it. This is the product of the sum and the difference of two terms. Alright, guys, I want you to memorize this pattern here. This is actually the same with previous slide that I have shown to you. Okay, if we are going to multiply these two binomials, then the result is always the difference of two squares. Difference of two squares, it's because its term here is being raised by 2. Then the operation here is subtraction. So this is read as the difference of two squares. Square of A minus square of B. Okay, so of course, this is the lesson is all about. So we need to determine the factors of this. We need to factor this one completely. Of course, how are we going to do that? Okay, we will do the reverse operation. Alright? So this is the expression, the difference of two squares. Then, the first thing that we're going to do is draw two blank parentheses with opposite operations, plus and minus. Alright? Then, the next one is, we're going to factor the first term, a squared. And the factor of this should be written as the first term of the binomials. Okay, the factors are a, then a. Then we will do the same in the next term, which is b squared. Factor this one, and the factor should be placed as the second term of the binomial. Okay, and the factors are b and b. So this is now the complete factored form of this expression. Okay, so working backward. Alright, so this method, guys, we are going to apply in the succeeding examples. Okay, let us take this example. Write x squared minus 9 in completely factored form. Okay, we are going to apply the method that I had introduced to you just a while ago. Alright, solutions. Okay, this is the expression. Okay, we need to draw first two blank parentheses where the different operations, plus and minus. Then, factors of each term. Okay, the first term we have x squared, and these are the factors. Okay, so this factor should be written as the first term of the binomial. Then, factors of the second term, which is 9, and the factors are this one. So this should be written as the second term of the binomials. Alright, so this is now the complete factored form of this given expression. Okay, next example. Right, 16a raised to 6 minus 25b squared in completely factored form. We will do the same. Alright, solutions. Okay, this is the expression. Two blank parentheses with opposite operations. Then, factors of its term. The factors of the first term, 16a raised to 6 are, okay, 4a cubed multiplied by itself. Alright, guys, you have noticed that the exponent of the variable being divided equally. If we are going to multiply this one, the result is a raised to 6, if you could still remember the law of exponent. Alright, so these factors should be placed as the first term of the binomial. Then we will do the same in the next term, 25b squared. The factors are 5b multiplied by itself. Okay, this is now the second term of the binomial. Right? So this is now the complete factored form of this expression. Okay, next. Write a squared b raised to 4 minus 81 in completely factored form. Okay, we will do the same solutions. Okay, this is the expression. Okay, two blank parentheses with opposite operation. Okay, factors of its term. The first term, we have a squared b raised to 4, and the factors are ab squared multiplied by itself. Okay, this is now the first term of the binomials. Then we will do the same in the second term, which is 81, and the factors are 9 multiplied by itself. This is now the second term of the binomials. Okay, so this can no longer be factored out, so that means this is the complete factored form of this given expression. Alright, so next, write x raised to 4 minus 81 in completely factored form. Okay, so let me show you the solution. It's number 1. Okay, so we have two solutions in this case. Okay, this is the expression. We will do the same. Okay, two blank parentheses with different operations, positive and addition and subtraction. Okay, factors of the first term, we have x raised to 4. The factors are x squared multiplied by itself. This is now the first term of the binomials. Then factors of 81, we have 9 multiplied by itself. This is now the second term of the binomials. Okay guys, you have noticed here that this factor is actually the difference of two squares. Alright, so meaning we can still factor this out, except this one, because the operation is addition. So this is now fixed. So we need to work out with this factor. Okay, we have now our solution number 2. Let us just focus only with this expression, x squared minus 9. We will do the same. Okay, draw two blank parentheses with opposite operation, plus and minus. Then factors of its term, we have x squared. The factors are x multiplied by itself. Okay, this is now the first term of the binomials. Then the factors of the second term, which is 9. The factors are 3 multiplied by itself. Okay, so this is now the second term of the binomials. Alright, so finally, we derive with the complete factorization or the complete factored form of this given expression. Alright, next, number 5, write 3w squared minus 48 in completely factored form. Okay, so you have noticed guys that the two terms here are not perfect squares. So that means we need to come up with the right solutions. But if you're going to analyze the expression, they have in common. So we have what we call the greatest common monomial factor, or the GCMF, and the GCMF is 3. Okay, this is the GCMF and this is the other factor. How to get this? Okay, recall your learning about factorization by the greatest common monomial factor. Just divide this term by the GCMF and the result is this one, w squared. So with negative 48, if we will divide this one by the GCMF, the result is negative 16. Okay, take note also guys, observe the factors. If the factors could still be factored out, please do not stop. Okay, in this case, this factor here is will fall also as the difference of the two squares. Both terms here are perfect square, so we need to work on this. Solution number 2, let us just focus only with this factor. Okay, so we will do the same. Then draw two blank parentheses with opposite operation, plus and minus. Then determine the factors of this term w squared. The factors are w and w. This is the first term of the binomial. Then do the same in the second term. We have 16. The factors are 4 and 4. Alright, so we will now derive to the final answer, which is 3 times quantity w plus 4 times quantity w minus 4. This is now the complete factored form of the given expression. Alright, so thank you for spending your time guys in watching this video, and I hope you learned something. See me in the next video, and happy learning.